In this video, we're going to be taking a look at the Flashforge Adventurer 5M Pro. Now there is a non-pro model available for those of you guys on a tighter budget, so keep that in mind. And Flashforge has been in the 3D printing game now for over 10 years. So surprisingly, this is my first FDM Flashforge printer. I did do a review on one of their resin printers in the past, and technically I do own an older Adventurer 3 that was rebranded by another company. Now that little machine has been going strong until this day. It's quite the little workhorse for what it's worth. So I'll be walking you guys through the unboxing, the setup, the ins and outs of the slicer, an upgraded spool holder, a ton of prints, and finally at the end of the video, I'll give you my thoughts. We've got a lot of stuff to get through, so let's get started.
We'll begin with the unboxing, and the Flashforge Adventurer 5M Pro comes sufficiently packaged inside of the box with lots of foam and a generous amount of plastic covering all of the pieces that might get damaged, so you can expect that all of those clear panels will not be scratched. Once you've removed all of the protective plastic, inside of the printer itself is where you'll find all of the accessories. There's a sample roll of filament that you can fish out of the top, and then through the front of the machine is where I pulled the accessory box and the rest of this foam. Now for the first time, you can see the vast emptiness of the inside of your printer with a 220 by 220 by 220 millimeter build volume. At this time, you can just do a general visual inspection of the inside, take a look at the print head, and make sure that nothing arrived damaged. And if everything looks good, you can move on to the next step and take a look straight down. You'll find 4 yellow arrow stickers, and those screws are going to point to 4 screws that you're going to need to remove before we power on the printer. Pull them all out and put them aside. We won't be needing those again. Now we can take a quick look inside of the accessory box, and what we'll find is a pretty typical set of accessories for a 3D printer, including some generic tools, the filament spool holder, some grease, a tool for clearing filament jams, a spare hot end, a USB stick, a glue stick for bed adhesion, which hopefully we won't have to use, some side cutters, and some generic hardware. With everything unboxed, we can now get the printer set up and assembled. And luckily for us, the printer comes 99% pre-assembled. One of the few things to do here is just attach the filament spool holder at the back of the machine. There's a small bag of hardware included with the accessories and the spool holder itself, and it just screws into the back of the machine at this location. Then we can load in a roll of filament, start to feed it through the filament tube, plug the machine in the back, and press the power button at the front. You'll be greeted with the Flashforge splash screen, and then the machine will walk you through the initial setup where you'll choose your language and go through the calibration process, which is completely hands-off. Just make sure you have your machine set up on a very stable surface, as this calibration process includes the vibration compensation, so it's going to be pretty normal for you guys to hear and potentially even see the machine shaking a little bit. Then when that's done, we can load in some filament. There are some on-screen instructions to guide you through this process. A moment ago, I had already fed through some filament, so when I go to remove the PTFE tube from the top of the print head, you could see it starting to poke out. Then I'm going to take that, I'm going to press that into the top of the print head, press the load button, and this is going to preheat the hot end. And once the hot end has reached the predetermined temperature, the gears inside of the print head will draw the filament in, and it will start to purge at the nozzle on the bottom, and the filament loading process will be complete. And at this point, you're technically ready to print. It's very quick and very painless to get this machine up and running. But before we get printing, we'll have a quick look through the menus, and on the first one is preloaded files onto the machine that we can get printing. Now there is an option to access files on a USB stick. We'll do that a little bit later. On the second tab is the filament, where you can load and change filaments. The third option is the machine settings. And on the first tab, we've got the position settings, where you can jog the axis or the print bed. Second tab is the Wi-Fi settings. Then we got Flash Cloud. We can also rerun the bed leveling, as well as the vibration compensation testing. And in the tab after that, we got camera settings. And in the final tab, we've got the internal and external filtration settings. And finally, the last icon in the bottom left is the machine information, where you can find your serial number and perform firmware updates. We're going to go back to the Wi-Fi tab, and I'm going to turn the Wi-Fi on. I'm going to select my SSID for my local Wi-Fi, and I'll enter the password, and you'll see in the top right corner now, the Wi-Fi icon appears, indicating that we are connected to the network. And if you're on a network with internet access, you'll likely be prompted to update the firmware. I'm going to go ahead and let the firmware update run, and then restart the machine, and we'll be back on the home screen, and we can select a sample test print to run. And instead of running a Benchy or a calibration cube, I'm going to go ahead and run this concave dodecahedron sample model, which is intended to be printed in PLA and says should only take 38 minutes. I didn't have to make any adjustments to the Z offset, and I very carefully watched the first layer go down. It went down flawlessly, and the rest of the print went off without a hitch. I didn't notice anything unusual, and all the layers were looking quite smooth. No signs of anything abnormal, such as print blobs or other inclusions or artifacts. The only real thing that I did notice was a little bit of stringing once I took the print off the print bed. Now this is something that I've noticed with this filament eSun PLA Plus that's been happening to me a little more recently. So it might just be time for me to dry this filament. Either way, it's nothing of great concern at this point, as the wisps can be easily removed with a heat source like a heat gun. I'm not going to attribute it to the printer just yet, as this was a preloaded file. I didn't slice it, so I don't even know what settings are used. Perhaps it's something that I can tune out. And that's a perfect segue into the next topic, which is the slicers available, as we have a few options to work with. If you go on the Flashforge website, there is FlashPrint 5, which appears to be Flashforge's own internally developed slicer. On their website, you can also find an alternative slicer under the 3D printers category. If you click on Flash Maker and scroll down, you'll find a download link to Orca-Flashforge, which would be a forked version of Orca Slicer specifically set up for a Flashforge printer. So we'll download that one as well, and we'll take a look at both of them. We'll start off by taking a look at FlashPrint 5, and upon launching it, you can see it's in light mode, which is burning my eyes. So if you hop into the settings, we can change that into the dark theme, and we can also make the font size a little bigger. You may also notice that the print bed shape right now is rectangular, which doesn't match the Adventurer 5. So we can fix that by going into Print and then Connect Machine. And if your machine is on the same Wi-Fi network as your computer, it should pick it up. We can connect the machine and the print bed shape and size will change. And then we can use the menu in the top left to add a model. And you'll see all of the other controls on the right-hand side, where we can move and rotate the model, scale it, cut it, duplicate it, use auto layout, add supports, control a wiping tower, and much more. If you plan on using this slicer, personally, I would get familiar with the support options and learn how to use the manual supports. This model is pretty simple, so we won't be doing that just yet. I'll click on Start Slicing in the top center, and you'll see the slice menu comes up, but we want some more advanced options here. So I'll click on Expert Mode, and you can see we have much more control over the slicing options now. The default print settings for PLA only has 2 outer wall layers, so I'm going to increase that to 3 layers, and then I'll hop into the infill settings and change the infill density to 18% and change the infill pattern to triangles. The modified print settings shouldn't have an impact on the print quality, but rather just the strength of the part. And the reason that I didn't want to change anything related to the print quality is because we're going to be doing a head-to-head comparison between FlashPrint 5 and the Orca Flash Slicer. Since both of these slicers are officially supported by Flashforge, I wanted to see if there's any reason to go with one or the other. So at this point, I'll save this print profile under a new name so I don't have to make those changes later. I'll click on the Slice Preview. Now we can get a nice preview of the expected printer output. At the bottom of the screen, there are sliders to step through each layer of the print, and on the right-hand side, you can also preview each of the G-code lines. At the bottom, you can also toggle some of the options to view the current layer only, retraction, and travel moves. And you can also use the second slider to walk through each of the toolpath moves. Then we can use the Send to Printer button at the top of the screen, name our file appropriately, and send it right off to the Adventurer 5M Pro over Wi-Fi. Once file transfer was complete, I walked over to the printer and happily found it preheating and getting ready to start the print. And as with the earlier first test print, I stood around, waited, and monitored the first layer going down to make sure there were not any issues. This part's first layer covers a more substantial area than the initial test print, and it looks like the auto bed leveling is working very well because of the uniformity of the first layer. As this print progresses, you'll see that this model contains some mild overhangs as well as lettering on one of the round faces. We'll move on to more intricate and challenging models later, but I think this is a good progression from that first test print. And you'll see here that with this model, there are almost no very fine wisps of filament as in the first test print. So it may just be that the latest print settings in FlashPrint are more up to date and optimal for the printer. One of the things I did notice though is that there is a bit of ringing and ghosting around the lettering. The lighting that I'm inspecting the part under does make it look a little worse than what it actually is, but it's definitely there. The other thing I noticed is that the top solid layer is looking a tiny bit rough, and I can feel that with my fingers. So perhaps those settings could be optimized in the slicer. I'll have to play around with that a little more. Otherwise, the rest of the part looks great. Again, first layer was absolutely flawless. The lettering on the first layer, very legible at the bottom. The Z seam is pretty obvious in this black filament. I wish I could control the position of it, but I didn't notice any means to control that inside of FlashPrint 5. Now we can print the same object in Orca-Flashforge, and when you first launch it, it's going to ask you to select your printer type, and then you can select the various materials that you expect to be working with. Lately, I've been using Orca Slicer to slice files for most of my other printers, so I'm a lot more familiar with this environment, and I do really appreciate the fact that this is one of the officially supported slicers. It's also nice to see that FlashForge has not limited access to any of the options or controls within Orca Slicer, so you'll pretty much have the full suite of options at your fingertips. Upon first inspection, it looks like they've mostly just preloaded all of the configurations and presets specific to their machines. Now, this does mean that FlashForge should be maintaining print profiles for the two different slicers, so I'm going to be using the default PLA profile with the 0.2mm standard layer height, and I'm just going to make the exact same changes that I did in FlashPrint. So I'll be using a 18% infill triangle pattern as well as the 3 outer walls. The only other change I'm going to make here is painting on the Z seam, of course because I can in this slicer, whereas unfortunately in the FlashPrint 5 slicer I could not do that. On this particular part, I like to have the Z seam away from the text on the front of this round object. Now, obviously this is not a tutorial on how to use this slicer, and while you might not be able to find necessarily as much information on the Orca-Flashforge variant of the slicer, again, it's exactly the same as regular Orca Slicer, where you'll find tons of information on that if you just search Orca Slicer tutorials on YouTube. This time I opted to send the file to the printer instead of automatically starting the print because I wanted to check in the file list that the print preview in that thumbnail would show up properly, and it does. It shows up in this bluish color, which is nice because now you can easily differentiate between what was sliced in Orca-Flashforge versus what was sliced in FlashPrint. And since we already watched this part get printed once, we'll skip right to the final result. For the most part, it looks absolutely identical to the part printed using the FlashPrint slicer. However, the ghosting and ringing around that lettering does appear to be worse. I should mention that this part did finish about 5 to 10 minutes faster than the variant on FlashPrint, so that might have something to do with it. I'm hoping that's something FlashForge can eventually tune out with the settings within the vibration compensation, and perhaps that can be something done on a firmware update in the future. The one thing that did look better on this print, however, was the top solid layer. It looked and felt quite a bit smoother than the one produced on FlashPrint, but I would say that the print profiles between the two slicers are very close, so it seems that FlashForge is actively maintaining both of them. And just for good measure, we're going to use a third slicer, and that's going to be the regular version of Orca Slicer. There is a preset in the printer selection for the Adventurer 5M Pro. Now, I don't know if these presets are provided by FlashForge or if they're community developed. I did a side-by-side comparison with all of these settings in Orca-Flashforge, and mostly everything was in line. And so I'm going to go ahead and expect that the output from regular Orca Slicer and Orca-Flashforge is going to produce similar results, but you never know. To keep things consistent across all three slicers, I went ahead and made the usual changes. So I increased the wall count to 3, increased the infill density to 18%, changed the infill pattern to triangles, and in this case, painted the seam position on the back of the model. In the print preview, things are looking very much the same as Orca-Flashforge, and even the print time is almost identical. The only issue that I ran into when using the regular version of Orca Slicer was trying to get it to send the G-code file over to the printer wirelessly. Simply using the machine IP address in the field for the IP of the machine didn't work, and Orca Slicer wouldn't detect the printer. I also tried adding the port number to the end of the IP address that I had found in FlashPrint 5, And unfortunately, that wasn't successful either. It still couldn't detect the printer. So in this case, when using Orca Slicer, I was limited to using the USB stick, which is easy enough. But if you guys have any suggestions on how to get that to work in Orca Slicer, please leave a comment in the comment section down below. I'd love to hear from you. So I'll cut right to the inspection of the 3D printed part using Orca Slicer. And as I expected, it looks more or less the same as the version printed in Orca-Flashforge. We've got a pretty similar ghosting and ringing around that text, which I'm not crazy about, and a slightly rough, maybe even under extruded top solid layer on this portion of the print here. Now that could be a pretty easy fix in the slicer. As for the ghosting and ringing, that one I'll play around a little bit with the speed and maybe try and reduce the speed on some future prints, but overall, I would say that the FlashPrint 5 print was the cleanest because of the least amount of ghosting and ringing. So with that out of the way, I will be trying to use FlashPrint 5 for most of the prints going forward, unless I need some of the more advanced settings with Orca-Flashforge. After all, you would hope that FlashForge's own slicer would work best with its printers. So now I'll print a few more things, and in FlashPrint 5, I'm going to go ahead and load in a few more objects. The first of which has a few overhangs, one of which is about a 55-degree overhang. The second part has some areas that need to be supported. And for those 4 circular pockets that require support, I'm going to use the auto supports. I'll give that a shot. Right now I have it set to using the regular grid supports and not the organic tree-like supports. And so you can see it's generated that support in those circular pockets, but it's also generated some support in this very short bridge section, which I don't need. So I can just click on those and delete them. Then I can click on start slicing and hop into the print settings. And in here, I'm only again going to change the shell count. So I want 3 outer walls, and I'm going to change the infill and infill type. I'll have a quick peek at the output, and then I'll send it off to the printer again wirelessly. And in a few moments, the print will have started and we can check out that first layer. It looks to be pretty consistent with the other prints that we just completed. It could be just a touch too close, but it doesn't seem to be causing any problems. So for now, I'm going to leave that. Watching the infill get laid down, I can see a tiny little bit of stringing, but it does seem to be contained within the walls of the model. So at the end, we'll take a look and see if it's on the exterior at all. But for now, it doesn't seem to be a problem. And while that print's running, I do want to point out that you can watch a live stream of your print with the camera inside of the Adventurer 5, and you can do that from your web browser by using the IP address, followed by a few characters that I've got up on the screen right now. It wasn't long before this print was done, and things were looking mostly pretty good. Some of that stringing that I noticed on the infill did end up on the exterior of the model. Again, this is pretty easy to clean up, but it would be nice if it wasn't there. Most importantly though, all of the walls were looking very uniform and the layer lines were crisp and consistent. The ghosting and ringing around the lettering wasn't too bad in this model here, as it was sliced in FlashPrint 5. And while it could be seen in this harsh lighting condition on other stop-start areas of the model, it again wasn't too bad. The second part on the print bed printed successfully. However, it does have a lot more flat surface area on the top, and you can see that that flat area is again looking kind of rough. The bottom surface looks nice and uniform with the texture transferred from the textured build plate, and the auto-generated supports pop out fairly easily with some very light prying with a hobby knife. After finishing that print, I noticed that I was starting to run out of filament, so I figured why not print the same model again and test the filament runout detection sensor. So I let the filament run out and then waited and waited and waited, and nothing seemed to be happening. The printhead started printing in the air, at which point my print was mostly going to be ruined, so I let it continue, and I decided to check out some of the settings while the print was running and realized that the filament runout detection sensor is not enabled by default. Now I don't know why it wouldn't be enabled by default, but as soon as you turn it on, the sensor trips and you can do a filament change. Since we'll be changing filament at this point in time, I'll show you guys a filament related upgrade that I've got that's compatible with the Flashforge Adventurer 5M Pro. It's what I call the Spool Stand X, and it's available on my website embracemaking.com. It features a threaded spool holder that has 2 opposing conical surfaces to hold a wide variety of spool sizes. You can quickly and easily swap spools, and the spool is no longer inconveniently located at the back of the printer, and it actually spins on its center axis now, unlike on the Flashforge spool holder at the back, where it gets dragged across that metal bracket. This reduces friction in the filament path, and now the extruder doesn't have to pull quite as hard when extruding, and that should lead to less instances of under extrusion. The other cool thing is that you can run the Spool Stand X in this orientation, and you can put it on top of the lid of the printer if you don't have a lot of room on the side. Plus there's a few other accessories and options like a PTFE tube guide that will attach to the Spool X frame. You can check those out all on my website, embracemaking.com. Now that we've got the filament changed, we're going to take a look at a slightly more challenging print. It's a taller part on a smaller base. There's a lot more gaps in this football shape that should lead to a lot more stops and starts and retractions. I'll be slicing it in FlashPrint 5, and because of that smaller base, we're going to be going into the additions in the slicer settings, enabling the brim, and I'm going to increase the size of the brim to 6 millimeters. This should hopefully prevent the part from getting knocked over during the print, especially while the print head is working its way up to the top end of the model. And we can now send this off to the printer wirelessly, and then we'll wait very patiently for this print to end because it is about a 4-hour print. The print finished successfully, and it was printed in this magenta pink Sunlu PLA filament. And this was a brand new fresh roll of filament right out of the bag, so I was pretty confident that there was no moisture, and I didn't see any major stringing, but there were still these very fine wisps of filament present. They can easily be blown away with a heat gun, but it's a little bit annoying that you have to do that. Otherwise, the brim was easily removed, and there's only a minor cleanup required where the brim was attached to the model. That's pretty normal. The outer perimeters of the model looked respectable, especially at the top of the print, where I felt that any sort of movement or vibration while the print was running would get amplified at the top. So overall, I felt it was a pretty decent print, and I ended up printing the bottom half of this model with the exact same settings. And as you would expect with the exact same settings, you get the exact same results. Some very minor wisping between those hexagons. But the two features that I was actually most interested in with these two parts was the male and female threads. So you can see on this bottom half, there's a male thread, turned out looking very good. And on the top half, there's a female thread, and the two of them fit together very nice. Now, as much as I love pink filament, we are going to be moving on to a different color. And this is a good opportunity for me to show you guys one of the features of the machine, which is how it handles filament changes. And that's because it's ever so slightly different than other machines that I've encountered in the past. So in the filament menu on the touchscreen, you can look for the icon with the 2 rolls of filament being swapped. And you can see that it's been preset right now for PLA. If you press that button, you can switch materials, and you can find other materials such as PETG, and then you can just hit the start button. That's going to preheat the nozzle. And while that's happening, you're going to want to pull back the PTFE tube and trim back your filament. When the nozzle reaches its target temperature, it's going to start feeding the old filament through. You're going to see that disappear into the print head, and that's when you can start feeding in the new filament. So the reason that I'm showing this is that on a lot of other machines, part of the filament change procedure includes some sort of retraction where the old filament comes back up and out of the print head, but in this case, it just purges the old color all the way through until you see the new color. I've now changed over to some sparkle gray PLA, and this is going to fit really well with this RoboCop bust that we're going to be printing. This is a larger model, and I really don't want to waste a lot of filament on the infill. So in FlashPrint 5, there are very limited infill selections. And so I'm going to switch over to Orca-Flashforge, and this is going to unlock a lot more infill options. And I'm going to go with Support Cubic in this case. I'll slice the model, and I'll check out some of the overhangs here that are going to be a problem when printing. And this is also one of the reasons that I switched over to Orca-Flashforge. It has a much more powerful paint on support tool that is so much easier to use. Just ignore those little red blobs there. Those are actually support blockers. I kept on accidentally right-clicking with my mouse, which just paints on an area that you do not want support. And in this case, I don't want support there anyways, so it doesn't matter. I'm just going to leave those. In the support menu, I'm going to switch over to manual tree supports. And when I go to slice the file, you'll see those manual supports come in where I painted the support enforcers. If you guys haven't already been using the organic or tree supports for a while now, you're really missing out. I would highly recommend them for models like this that are a much more organic shape, but I do find myself reverting back to regular grid style supports when I'm just supporting things like counterbore holes or regular flat surfaces or voids within a model. The 3.5-hour RoboCop body print was a success. The tree supports easily broke off. You can see they came off as I actually removed the print from the print bed. The Sparkle Gray does an amazing job in hiding the layer lines, and this is a higher quality filament, and I wasn't seeing the fine wisps that I saw with some of the other less expensive filament. Those very small blob looking things there were just maybe deposits from the nozzle because they weren't actually stuck to the model, so they just came off very easily. The printer did a very good job with all of the finer details of the model. The only thing that was a little bit rough looking was the overhang area that was supported. Now it does come up on an angle, so it's a little bit weird to support, but the area up here around these hooks was not supported, but they didn't actually need support to be printed even though they were on a bit of a challenging angle. Now in this version of the story, this Tin Man needs a brain, so let's give him a head, and we're going to be working again in Orca-Flashforge because this model is going to need some more advanced supports, and again I want to use that support cubic infill. There are quite a lot of overhang areas on this model that needed supports, and I didn't want to paint them all on manually, so I just went ahead and set it to auto, and you can see how much of it was generated. Now it was ever so slightly more challenging to get this stuff off this time, but with a good firm pull it came off, and it did leave a lot of artifacts on the underside, especially towards the back of the helmet. But I was looking more at the print itself in terms of the outer perimeters, and you can see along that curved surface that makes up the top of his head, those layers came in looking really smooth. That was the part of this model that I was most impressed with, along with the details around the area of his face that is exposed, such as his lips. Under his chin was a larger area that was fully supported, and that came out looking a lot cleaner than the very small areas, especially again towards the back of the helmet, where they were supported, and there are some artifacts there that could use a slight cleaning up, maybe with some sandpaper or a hobby knife. The square peg and hole feature to locate the head on the body worked out perfect. Dimensionally, this printer has been very accurate for me, and I've printed a ton more models than what you're seeing in this video, many of which are actually functional models that require dimensional accuracy. The stuff that I like to show you guys in these videos are more eye-catching models, such as these recognizable characters, but in reality, the most of what I'm printing are functional parts. They're just a lot more boring to look at. So in order to hopefully keep you guys entertained, I've gone ahead and printed Spider-Man, and with the exact same settings as the RoboCop bust that we just did, I used Orca-Flashforge, and I painted on most of the supports that were required underneath his arm and underneath his chin. This model was printed in a matte red filament from Elegoo, and the matte finish on the Spider-Man looks excellent. The majority of this model turned out on the good to excellent range. However, I do find that matte filaments can be a little funny to work with. From my experience, sometimes they hide a lot of the imperfections, and then in other models, they tend to bring out more of the imperfections. It can be a bit of a mixed bag, but that's just my experience. So in this model, there were some small areas where there is the webbing pattern on his body or on his suit, where you can see some slight imperfections, but you guys also have to remember here that I'm not tuning the settings for each of the filaments specifically. That's mainly because I'm trying to demonstrate the results that you'll see from a printer like this as a beginner user, just throwing different brands of filament at it with the default profiles. If you're looking to print more than just PLA, the Adventure 5M Pro can also print in PETG as well as many other different types of filament. But PETG is very popular specifically for certain functional applications, but it's a little more temperamental to print in my experience. So one of the things that I've done here is I've tweaked the standard PETG profile because I had a lot of failures using the standard profile. So one of the things I did was increase the Z offset in the printer settings to 0.06 millimeters, so it's going to bump the nozzle slightly farther away from the print bed. I also decreased the first layer line width to 0.4 millimeters, and I decreased some of the speed settings, specifically the ones related to the infill speeds, because those were quite high and I was getting a little bit of under extrusion on the infill. Now, one of the other things that I did to help with the under extrusion was to increase the nozzle temperature in the material profile. So I increased that to 275 degrees for all other layers. The first layer went down at 245 degrees. I also increased the bed temperature to 80 degrees to prevent warping. Now, this is where I find PETG and PLA differs a lot, is with these temperature settings. I find that with most brands of PLA, I can get away with printing at about the same temperature, whereas with different brands of PETG, there's a huge swing in the required temperatures. So in this case, I'm using some locally branded PETG. So 275 degrees might seem very high for generic PETG, but that was what was required for the brand that I'm using. If you have your own brand that you're familiar with, you might be able to get away with something a lot lower, like let's say 255 degrees. With all that said, you can see some of the parts being printed here, and on the first layer, by bumping the nozzle away from the print bed a little bit, you're not at risk of the PETG being squished so much that it's going to stick to the nozzle, which is a common problem with PETG. And as for the rest of the parts, you can see with the orange part, there was two parts of the model where the print head would have to travel back and forth, so there's some travel moves involved. And these white parts here, I put multiple parts on the print bed as I wanted to make sure that there was not going to be any stringing between the different models or sections of the model, and there wasn't. So looking at this orange part, you can see that the outer perimeters look pretty good, although you can tell that I was printing at an elevated temperature. The first layer was also pretty good with a slight bit of lifting in one of the corners, and the top surface in this case was very smooth compared to what I had seen with some of the other PLA prints. You guys might recognize this print as one of two parts of a broomstick holder, which uses this gear and gravity to hold a broomstick in place, so the two parts will fit together. The white part was also printed in PETG. It came out looking pretty clean, and when the two parts are placed together, you can see that they fit together perfectly. So the takeaway here is that if you're printing with PETG on the 5M Pro, you're probably going to have to play around with the print presets. For me personally, I'm probably going to try and slow down the profile a little bit, or perhaps even reduce the volumetric flow rate, which will also drop the speeds, and that way I can lower the nozzle temperature and not run into under extrusion issues, and then I'll end up with cleaner outer perimeters.
So that brings us to the review section of this video, and overall I've had a great time so far with the Flashforge Adventurer 5M Pro. I really wish that the firmware would keep track of the print hours on the machine, because I would love to show you guys how many miles I put on this thing in my print farm. And other than the time where I was experimenting with PETG, I've only had one print fail on me, and it was a PLA print where it was more or less my fault because I did not adequately support that print when I went to slice it. So the machine has been really easy to set up and get going with. And because I've had few to no print failures, I think the machine would be a great printer for a beginner user. I've also never had any issues with dimensional accuracy. I print a lot of functional parts. The only thing that I thought could be improved quite a bit was the ghosting and ringing, which I saw on text on vertical walls. I showed that to you guys earlier in the video as well. And I also mentioned earlier in this video that I'm very happy there is an officially supported version of Orca Slicer for this printer, although I do think Flashforge has to check the acceleration settings being written to the G-code, because I think that might be the issue with the ghosting and ringing. That is something I'm going to check. Those values seem to be higher than what's in FlashPrint 5. Another detail that could use a little bit of improvement was the quality of the top surface layers, specifically in PLA. It didn't seem to be as much of a problem in PETG. So this tells me this could be something that can be resolved inside of the slicer preset for PLA. Now, otherwise, the printer is very comparable in terms of print quality, speed, and build volume to other printers in its price range. The Adventurer 5M Pro also has some features that you would expect from a machine in this price range. For example, the internal camera, which you can use for time-lapse photography, as well as the auxiliary part cooling fan to boost the part cooling capabilities of this machine. But it also has some unique features that I haven't seen too much on other printers. For example, it's got an exhaust fan, which in itself isn't too unique. However, it does have a recirculation capability, so there is no internal separate heating element for the chamber. But I think by recirculating the air in there and the passive heating done by the heated bed, if you close the door and the lid, that might be good for printing more temperature sensitive materials. And it also has some great features within FlashPrint 5 as well as Orca-Flashforge for controlling multiple printers. So if you had a print farm setup, it makes controlling that a breeze. Based on my experience with this machine, I'm excited to see what's on the horizon for Flashforge. I hope they come out with a consumer grade version of the 5M Pro with a larger build volume, or perhaps a machine with multi-material or multicolor support. And if you happen to be in the market for this particular model, just be aware there is a non-pro version of this machine. And if you're mostly just printing in PLA, that could save you quite a bit of money by going for the non-pro version instead of the pro. On their website, there is a comparison chart between the two, so you can see what features the non-pro versus the pro has. I would highly encourage you guys to check that out. So that's it for this video. Thanks to Flashforge for sending me the Adventurer 5M Pro, and thank you guys so much for sticking around right to the end. If you guys enjoy this content, be sure to check out my website, embracemaking.com, where you'll find lots of upgrades and accessories available for your 3D printer. It's a great way to support me and my work, and for you guys to get something in return. And if you guys are looking for anything else that you've seen in this video, you'll likely find that with links down in the video description down below. So go check that out. And finally, don't forget to subscribe so you don't miss my next video.